The challenge that I see in the open source is these models are going to get smart enough to where they're going to be able to deliver utility at the frontier to users while simultaneously defending against distillation. And if that happens, I question how much open source can keep pace. We don't know, but that to me is concerning. And I think, frankly, it's why Meta transitioned to the closed source model. They realized that they couldn't keep pace once the labs turned off their access to distill those models. And without investing completely in their own closed source environment, they weren't going to be able to be competitive. Again, open questions, but I'm curious how you're thinking about that.
I think you've hit on exactly the right point, Damon. The demarcation line is when we move from software into the physical world, and how that demarcation, how hard that is to surpass that barrier, ends up becoming the limiting factor for this recursive compounding growth that you're describing. I would assume, let's pick a couple of problems. Unlimited energy, for example. If you wanted to generate unlimited energy and you built a model that does the software part of that, generates the hypotheses, goes deep on every one of these permutations, nuclear, hydrogen, variety of other ways of achieving unlimited energy, improving solar cells, et cetera, you would then need to have a feedback loop in the real world with atoms. How you do that ends up becoming much slower than what a model can recursively do in pure software and ASCII, and therefore will come with regulation. Energy in particular is going to come with a lot of regulation, because any questions you're asking there could be benevolent for the good of humanity or could be malevolent for nefarious purposes, and so that will need to be closely regulated. Let's take another problem. You want to cure cancer. You want to cure all cancers. You're going to build a model focused on achieving those outcomes. All of those outcomes are to cross the Rubicon from digital to physical in atoms. Any of those experiments that you do could lead down the path of something beneficial to humanity with cures to cancer, or deadly agents that you could deploy in a nefarious way. And so there's huge regulatory hurdle, to go back to, I guess, the theme of the day, which is how does regulation fit into this world of AI economics and the AI state of things. That hurdle feels immense and varied across the globe. Every government's going to approach that differently. Where you experiment, how you experiment, what the role of the model is versus a human handoff. When you have the human handoff, all those things become, I think, really important and probably slow the process down a lot.
Yeah, I want to ask one other question. This takes the conversation in a slightly different angle, but is still on the regulatory theme. With this export control that has just been kind of delivered to Anthropic or imposed upon Anthropic, I think we're headed for immigration reform, because I don't perceive a world that can exist in which you can gate it on nationality anymore, because intellectual horsepower, specifically with respect to AI, is going to be a matter of national defense. And so I don't think we as a country, being the US, can simply say only the folks born in the US can work on AI projects. I mean, Andre Karpathy being the most notable example recently, right, was just hired by Anthropic for some undisclosed multiple millions of dollars to lead their recursive self-improvement platform, again, reportedly, can no longer work on frontier models. That doesn't feel like a sustainable situation to me. Any thoughts there?
We're going to need some coalition of partners. We as the United States need to get back to being the beacon on the hill. We need to get back to being global consensus builders and leaders. And we've lost some of that lately, but there's an opportunity. AI gives us an opportunity to regain that vision of a great country leading the world into the future in a way that's mutually prosperous. If we can build that kind of consensus with partners, we've had those partners. Some of those relationships are a little bit beaten up, but we can recover. We can get back to that. If we can build that consensus, then we don't need to think about national borders as being the thing that stops us from making progress. We can work closely with partners, for example, in Europe, who want to work closely with us, even in Taiwan, who want to work closely with us. There is an important aspect of this that you're highlighting as well, tangentially, which is the the technology we use comes out of, in many cases, Korea for memory chips, TSML, Taiwan for semiconductors. We're using parts that come from the leading engineering facilities around the world, but we're saying that those places don't get access to our best models, our outputs, and in a way that feels deeply unfair. And what I would suggest would happen as a potential second order effect of this is those countries that are building the very best hardware in the world, TSMC, SK Hynix, ASML in the Netherlands, these organizations are going to say, we are building the frontier. We're building the very best things that are getting assembled and put together for use, which is building these frontier large language models. And they're saying we don't have access to the models that are the derivative products of our work. This feels deeply unfair. If we don't do a good job of building consensus, of building a network of partners, of close relationships, trusting relationships across these borders, then those countries are going to decide, maybe we need to regulate our part of the value chain. If they're going to regulate their part of the value chain, maybe we need to regulate our part of the value chain and extract more value. And I don't want us to get down to this path where every nation is getting interventional about what their part of the supply chain is in large language models and semiconductors and AI, because that creates a higher tax for everybody, every user downstream.
Yeah, I think that's well said. I also think it's interesting where we've kind of already seen national backing of AI. Like the example that I'm thinking of is Mistral AI. And I think the challenge when you're talking about this technology specifically is that there are just very few humans in the world who are actually on the cutting edge of this. And even with state resources, it's near impossible to keep up if you can't recruit the latest and greatest in human talent to these things. And so, yeah, it feels, again, I mean, in many ways, we're all kind of building the airplane as we're trying to fly it here. But it is, I think, notable to me that regulation that we have pre-AI now trying to be retrofit into a world that is AI native and becoming increasingly more so is going to provide lots of challenges. And yeah, I think this is going to be one of many over the next handful of years that we see in which third parties are becoming key stakeholders in the progress of this technology in a way that has widespread ramifications to not just end users, but again, to your point, kind of multinational agencies, right? Whether that be kind of alliances across geopolitics or whether it be universities sharing access to information. We haven't even tapped into that. Is like, at what point can you stop publishing research, right? At what point can you stop presenting at conferences on the stuff that you're doing? Like, at what point do we really get to a world, kind of like the last few years of World War II, where you have state-held secrets around an entire division of, at that time, physics. Now, I guess you would argue it, a branch of mathematics,